Hello everyone, welcome to We Learn Tutorials. In this video, we are going to learn about chemical properties of acids. So before doing properties, let's understand the meaning of an acid. So acid is any substance which gives us H positive ion in its aqueous solution. So main thing you have to remember, any substance which gives us H positive ions in aqueous solution is an acid. In addition to this, you have to remember one thing, that this H positive ion is very unstable, due to which it will immediately react with water and gives H3O positive ions, which is hydronium ions. So this is just an additional information regarding this H positive ions, that this is very unstable and it reacts immediately with water to give us hydronium ions. But basically you have to remember, an acid is a substance which gives us H positive ions in an aqueous solution. So now we know these ions or this ion, they are not visible to our eyes. So how to recognize whether an acid is there or it's not there? So for that we have some indicators which help us to check the presence of an acid. So let's find out the names of those indicators. See, indicator, this word is suggesting me something which is indicating something. So indicator will indicate us that this substance is an acid. So very commonly used indicators are litmus. So litmus, it can be used in solution form also, and it is available in paper strips also. We have used blue litmus paper or red litmus paper. So it is available in strip form also. Then we have phenolphthalein solution, methyl orange, pH scale, and universal indicator. So all these indicators help in indicating the presence of an acid. So let's find out what will happen to all these indicators if an acid is present. So litmus paper, it will be changed into red color. If acid is present, or if we are checking the presence of an acid with litmus paper, blue litmus will be changed into red color. Phenolphthalein, this solution will be changed into colorless form. Methyl orange, it will also change to red color if an acid is present. On pH scale, we have values from 1 to 14. So values from 1 to 6 will indicate the presence of an acid. On universal indicator, we have 7 colors, and these are indicated by, or these are denoted by VIBGYOR. VIBGYOR means violet, indigo, blue, green, yellow, orange, red. If you are getting yellow, orange or red on universal indicator, this will indicate the presence of an acid. So let's revise it. Indicators, they help us in checking the presence of an acid. So indicators are litmus, phenolphthalein, methyl orange, pH scale, and universal indicator. Litmus paper, it will be changed into, or solution of liquid, it will be changed into red color. Phenolphthalein will be changed into colorless form. Methyl orange will be changed into red color. pH scale, it will give you the values from 1 to 6. Universal indicator, it has 7 colors, and if your colors are yellow, orange or red, then it will indicate the presence of an acid. Now let's talk about some chemical properties of an acid. So before doing properties, I want you to understand that we will use only these acids: sulfuric acid, nitric acid, and hydrochloric acid. So if we are doing any chemical reaction, we will use all these three reactions, all three acids: sulfuric acid, nitric acid, hydrochloric acid, in dilute form. And while doing reactions with metals, we can use any metals except mercury, silver, gold, copper, and platinum. We won't use these metals in any of our chemical reactions, since these metals are very least reactive, and in case of using acids, we will only use these three dilute mineral acids. So now let's do the reactions. So our first reaction is reaction with metals. Reaction of acids with metals. Since we are doing chemical properties of acids, so we will check how acids will react with certain substances. For example, how acids will react with metals, how acids will react with metal carbonates, metal oxides. So all those things we are going to do. First of all, our reaction is with metals. So I have already told you we can use any metal except from copper, mercury, silver, gold, and platinum. And the discussed acids we will use sulfuric acid, nitric acid, or hydrochloric acid. So let's write the general form of this chemical reaction. So when acid reacts with metal, I can write it in this way: acid plus metal. It will give us hydrogen gas. This arrow mark is used to represent the gaseous state, plus salt of that metal. So this equation can be used to represent the general form of this equation or this chemical reaction. When acids are reacting with metals, they will give us hydrogen gas plus salt of that metal. So let's take one example. We can take any metal. So I will take zinc plus sulfuric acid, H2SO4. You have to refer to this equation while solving this chemical equation. So it will give us hydrogen gas. Now salt will be of this metal. This metal is zinc. I will write zinc as it is. And this hydrogen part of sulfuric acid is already utilized here. So this is now left over. So I will use this to complete my metal salt. So I will get zinc sulfate. See, this reaction was very simple. Zinc plus sulfuric acid. I know acid plus metal, it will give us hydrogen gas plus salt of that metal. Now we can see hydrogen gas I have already written. So in order to know which salt it's giving, I'll write metal first, then the remaining part of the acid. Now let's do one other example. Now I can take magnesium, and you have to remember that this acid should be in dilute form. Now we will take magnesium. We can take other acid now, HCl, again in dilute form. So our products are conformed: hydrogen gas plus salt. So hydrogen gas I will write as it is, plus metal I have to write first. I will write metal. Then this hydrogen is already utilized, chlorine is remaining. So I will write Cl2, and it will give me magnesium chloride. See, as of now I am not balancing the equations. I am just trying to make you understand the concept. You can balance the equations yourself. So now you have to understand, when acid and metals are reacting, they are giving us these products. So with this reaction, we do have one exception. So let's find out what is that. So I told you we can use these three acids: sulfuric acid, hydrochloric acid, and nitric acid. But especially for this reaction, when acid is reacting with metal, HNO cannot be used. It cannot be used. The reason is that HNO3 or nitric acid is an oxidizing agent. So it is strong oxidizing agent, we can say. So what will happen once this reacts with some metal? So HNO3 being a strong oxidizing agent, it will oxidize this hydrogen gas. Oxidizes hydrogen gas means in hydrogen gas there will be addition of oxygen, and we all know addition of oxygen is oxidation. Due to this addition of oxygen, it will form water. But our product should be hydrogen gas plus salt. So here we can see if we are using nitric acid, we won't be able to get hydrogen gas, since this being oxidizing agent, it will oxidize hydrogen gas, due to which water will be formed. So if you get a question in the exam that why this reaction is not possible with nitric acid, so you have to mention HNO3 is very strong oxidizing agent and it oxidizes hydrogen gas to form water, due to which this reaction is not possible. But again, we do have one exception with this acid. Just now we have told that it can't be, it is not possible, but this acid is possible with two substances or two elements, we can say. Those two elements are magnesium and manganese. This reaction is possible with nitric acid if we use magnesium or manganese as our metals. But the only thing is that this nitric acid should be very dilute. Very dilute means in water only 1 to 2% of HNO should be present. So now if you get how this reaction is possible, you can say this reaction is possible only with manganese or magnesium, and with the condition that HNO3 should be in very dilute form, which means it should be only 1 to 2% in water. So with this, reaction with metals has been completed. Now let's do the second one. So next reaction is reaction with metal carbonates. Metal carbonates or metal bicarbonates. See, this reaction is same for carbonates and for metal bicarbonates. Reaction will be same. So I request you guys to watch this video till end, because we are going to discuss all the chemical properties in this video, all the chemical properties of acids in this video. So now let's back to the question, back to the point. So now we are doing reaction with metal carbonates. Let's write the general form of chemical equation. Metal carbonate plus acid. So it will give us, the products will be sure. First is water, first is carbon dioxide, water or carbon dioxide, you can write any in any order. So carbon dioxide in gaseous form plus water plus salt of metal. So this is the general form of the chemical equation of reaction of acids with metal carbonates or metal bicarbonates. So if you are reacting metal carbonate with acid, you will get these products, or if you are reacting metal bicarbonates, you will get the same product. Same for both the things. So carbonates you can recognize at the end of the formula, CO3 will be there. Bicarbonate means HCO3 will be given. So now let's do some chemical equations. We can take any metal except from the metals which I have discussed at the starting. So I will take magnesium, since I have to take carbonate. So it will be CO3 plus acid. We have to take any acids we can take. it should be mineral acid plus in dilute form. Mineral acids, these are strong acids, and the condition is that these acids should be in dilute form. So now I can write down the products. It's given in general equation. I will get CO3 plus CO2 in gaseous state plus water plus salt. Salt, same way we will see. Magnesium, first we will write our metal, because we will get the salt of this metal which we have used. Now this H of acid has been used, you can see. So only SO4 is there. So this remaining part of an acid we will write over here, and our salt will get completed. So we will get magnesium sulfate. Now let's do one more reaction. Now let's take zinc carbonate. So carbonate, zinc I will write as it is carbonate CO3 plus, now we can take hydrochloric acid in dilute form. It will give us carbon dioxide plus water. Since we have already discussed, products will remain same. So salt, same thing, we have to write down the metal which we have taken, and H is already utilized over here, and now Cl is the remaining part of acid which we will write over here. So zinc chloride, zinc carbonate, see I am reacting metal carbonate plus acid, it's giving carbon dioxide in gaseous state plus water plus salt of the metal. Now let's take one example with metal bicarbonate. So we are taking sodium bicarbonate. I told you HCO3 means bicarbonate. Sodium is metal. So metal bicarbonate is sodium bicarbonate plus HCl. This is acid in dilute form. So I have written one reaction. Products I have written carbon dioxide and water will remain same plus salt. Salt, this is my metal sodium, and this is remaining part of acid. So I will write NaCl. So the salt which I will get is sodium chloride, carbon dioxide plus water. So this was a reaction of acid with metal bicarbonate. So in this reaction, one question is very common. How can we detect the presence of carbon dioxide? In exam, this question can be asked. So this is most commonly asked question. This is very simple. This carbon dioxide, it turns lime water milky. So when you pass this solution from lime water, it will turn lime water milky due to the presence of carbon dioxide. So the property of carbon dioxide, you have to remember that it turns lime water milky. This is the commonly asked question, and you can remember this. Now let's do the next property of acids. So the last reaction is reaction of an acid with metal oxide. So again we will write general chemical equation, acid plus metal oxide it will give us water plus salt. So this is the general equation, you can remember this. Acid plus metal oxide will give us water plus salt. Now we can take few examples. I can take zinc plus HCl we will take. See, this is metal oxide we have to take, zinc oxide I have taken, then HCl, any acid you can take provided it should be in dilute form. Any acids from the given three acids which we are using, it will give us water plus salt. Salt is zinc. Same way we have to write first which metal we are using and then remaining part of our acid. So it will be zinc chloride. Now let's take another example. Let's take copper oxide. Now any oxide, any metal oxide you can take, same acid or different also you can take. It will give us water plus, this is metal, copper, and this is my remaining part of acid. So it will give us water plus copper chloride. Now let's recap all the three reactions. This was the chemical properties of acids, and we have discussed three types of reactions. Now we will revise all the three reactions. We have done first reaction. It was acid plus water, acid plus metal, which gives us hydrogen gas plus salt of that metal. Second reaction we have done acid plus metal carbonate or metal bicarbonates. So reaction was same for both carbonates and bicarbonate. Products were carbon dioxide plus water plus salt. You can see in each of the reactions it's necessary that we will get some salt apart from other products. The third reaction we have done acid plus metal oxide. So in this reaction our products were water plus salt, and with this our chemical properties of acids has been completed, and in my next video I will do chemical properties of bases. Till then you can do practice of some more chemical equations and try to do balancing of equations also. Till then, take care, stay safe. Thank you so much for watching the video.